So I'm going to describe the decay of the T quark and anti-T quark in terms of the Rishon elements derived from combinatoric ordered pairs. First, let's take a look at the ordered pairs. The Rishon elements are derived from the ordered pairs of non-standard order of 1/2 S and T equals 2. S equals 1/2 and S equals 2 is the ordered pair of the combinatoric model that represents the T quark. And we can see here we have the ordered pair S and T that represents the anti-T quark. And given that these arose spontaneously out of the vacuum of space or the transformation of kinetic energy of some particle. First, let's look at the composition of, or we can say, what ordered pairs vectorly add up to make the T quark in terms of these ordered pairs. So first we have what we can call a generic anti-D quark, which has the ordered pair -1 and 1. And here's the actual representation for the D quark, the generic D quark, 1, -1. And let's look at this graphically. Graphically, we have it here. This is the generic D quark made of anti-T and 2 anti-V Rishons. And the anti-D quark here made up of a T and 2V Rishons. Now, in addition to the generic T quark, the generic D quark, we will have a scalar boson minus. This scalar boson minus and the scalar boson plus respectively transform the generic D and anti-D into the T quark. And we can see it graphically here, where we have the generic D quark and the boson plus, which in this case then creates a T quark. We'll see later that the quanta electric, spin quanta, and so forth will be consistent with the standard model. Now, in addition, we have this ordered pair 0, 0, which will be a combinatoric ordered pair associated with a anti-V prime and a V prime. We can look over here graphically. That includes 2 flavored anti-V primes and unflavored anti-V primes associated with the anti-T quark. Now we'll see how these quarks will decay into these T quarks into B quarks. So to transform from a T quark into a B quark, the T quark will emit a W boson. And we can see here the W boson will be combinatorically represented by this ordered pair minus 3/2 over 3, which will be represented by V prime assembly and a T prime assembly, which we can see graphically over here. We have a V prime Rishon and a T prime Rishon, which were composed by a pair of prime anti-T and T particles interacting with the scalar boson plus, and that composed this scalar boson 0 and this W particle composed of a V, a flavored V, and an unflavored T prime. Now here we have actually, since this initial T Rishon had a spin of minus 1/2, that minus 1/2 spin also was taken away with the W boson. And so these two together compose the W boson. And we'll see later that then we have a spin change from minus 1/2 of the generic D to plus 1/2. And we will see later that there will also be an interaction of these two flavored V and anti-V prime Rishons with these two unflavored V and anti-V Rishons to produce necessary scalar bosons, neutral scalar bosons, to provide the correct quanta of the standard model. And so, as we've said, we have this emission of a W boson, and then that W boson actually will interact with the anti-T quark and transform it into an anti-B quark. And so we have these two B quarks represented here combinatorically. So now we can see the composition of the B quark represented here as in this ordered pair. And what we have is the original generic D quark, but as we showed previously, its spin has been transformed from minus 1/2 to plus 1/2, and we have a neutral scalar boson composed of a prime anti-T Rishon and a T Rishon, and then we have a neutral scalar boson that we'll see will be composed of a flavored anti-V prime Rishon and a prime Rishon, unflavored prime Rishon, which we can see represented as this ordered pair, 1, 0, and this ordered pair 1, comma minus 1. And let's look at that graphically over here. So we have this generic D, which is the original generic D, except there's been an exchange of anti-T rishons to change the spin from minus 1/2 to plus 1/2. And then we have this prime scalar boson, unflavored scalar boson, and we have this flavored neutral scalar boson. And we'll see in the next video how this composition provides all the quanta expected in the standard model.